question 2 is more with these transformations. I kind of cut it off, but this top one says it's a 1 over x. This is one of our parent functions that we should know the shape of. The 1 over x graph is what we have referred to all along as a butterfly graph. Try to get the one. So our butterfly graph, our original function graph looks like, try to make it more obvious, this graph here. This is the parent function that we are committed to transforming into the red graph, which they have labeled g of x. So first thing we're going to do is describe how these graphs are related. Whenever we've done these, I've requested that you give me at least 3 defining characteristics of any graph. On our inverse power models, some of the most defining characteristics of this graph are these vertical and horizontal asymptotes. These are two of the defining characteristics I would always graph on any butterfly or volcano graph. And anytime you have just back that up, anytime you have an asymptote of any variety, I would track and see where that goes, because that's going to tell you a lot about the shape of this graph. So what I'm going to do is I'm going to see, are there any horizontal or vertical translations in this graph? So I'm thinking, did we take this and shove the graph horizontally left or right? Did we have any vertical transformations up and down? The best way that I can track those is through the asymptote behavior. So I'm going to take this graph and say, well, did this horizontal asymptote stay at 0? It doesn't appear to. It looks like it got moved up 1 unit. So, okay, my vertical translation had to go up 1 unit. Then I'm going to do the same thing with the vertical asymptote. Did the vertical asymptote stay at 0? Nope. It looks like it got shoved 2 units to the right. So that's a horizontal translation. So we went right 2 units. So with these two ideas in mind, I can start building my new transformed equation. Let me point out something that many people were doing on their quiz. They said, well, I'm going to take the ordered pair 1, 1 on my parent function. I'm going to see how it got transformed to a 4, 2. And you said, well, I'm going to add 3 to the x's, and I'm going to add 1 to the y's, and therefore I'll know I had a horizontal translation. So they were doing horizontal translation 3 units to the right, and then they were going 1 unit up. Well, this was okay, but this is being thrown out. The reason the horizontal transformation is getting thrown out is because there's also a vertical stretch in this graph that we have to pay attention to. So that is why it's important to get this in the correct order as well. Go grab those asymptotic behaviors and see where they got moved to so that you can start writing a new equation. So our parent function is f at x equals 1 over x. So now if we're going to do the transformations we've already identified, the horizontal transformation has to go within the grouping symbol. Our fraction bar is our implied grouping symbol of x minus 2. We got moved 2 units to the right. And then we went up 1 unit, so that since that's a vertical, we go outside the grouping symbols and we add our 1. What we haven't accounted for yet is this factor of a. Did we multiply this times a and do any type of vertical stretching or shrinking? So what we're going to do is we're going to use the ordered pair that they've identified for us to help us do that. So that's how come, or why, they supplied us with the ordered pair 4, 2. The ordered pair 4, 2 gives us an x value and a y value that our new graph must go through for g of x. So really I'm working on g of x at this point, and we're going to figure out if we can find the stretch. So what we do is we place in place of the g of x, which is a y value, the 2, we're going to calculate what our a value is. What was that stretch factor? If we know the x input had to be a 4 minus 2 plus 1. So then we're going to have 2 equals a times 1/2 plus 1. Solving this for a, I'm going to subtract 1. So a equals a times 1/2. And to get rid of multiplying by 1/2 and multiply by 2. So it gives us a stretch factor of 2. So now we have also a vertical stretch of a factor of 2 times 2. Remember, whenever it was a value that was greater than 1, it was a stretch. When it was a value between 0 and 1, it was a shrink. So if you happen to get one that had a half instead of a 2, it would shrink it. So what I want to do is I want to create a transformed equation with all the given information that we have. So my new function g of x should be 2 times 1 over x minus 2 plus 1, which is equivalent to 2 over x minus 2 plus 1. And then I'm going to do the description. I'm just going to abbreviate here. We have a horizontal translation of 2 units to the right. We had a vertical translation of 1 unit up. We had a vertical stretch of a factor of 2. So we stretched it by a factor of 2. That is how I'd approach question number 2 when they give you a graph and a point that has some vertical stretch going on in it.